Hey environmental science students, we're going to do some calculations with survivorship curves. If you haven't already, make sure you do the survivorship types skill so you can practice identifying types 1, 2, and 3. But more important than knowing if it's the type number is understanding the pattern. So what you want to notice is that type 1 here has, type 1 will have a late loss pattern where most of the individuals survive to adulthood. So think about big mammals that spend a lot of time caring for their young, so a lot of young survive. And then type 2 is where we have an equal chance of survival all through life. A lot of rodents follow this pattern. And then type 3 is an early loss pattern. So you can see in the beginning, there's this huge drop off where most of the animals will not survive, or most of the individuals, I should say, do not survive that very first part of life. So in this example, we have a frog that may lay many eggs, but few of those will ultimately survive to become adult frogs. There's a small chance of survival in that egg stage in the very beginning. So just like this, that drop off is what you're looking for. So now we're going to answer some questions about it. The first question, which type of survivorship, is shown here. So you would choose type 3. And then what does this survivorship type mean for the frog's chances of death throughout their life? So we would say their chances of death are high early in life. So opposite of survival, so high chance of death early in life. To find the percent that survive at a certain number of time, what you can do is if you hover over, this is a screenshot, but on yours, if you hover over a graph, it'll show up a little ordered pair like this, so you can see what a given x value's y value is. So if you hovered over here at 9, if yours was giving you 9, you could see the number. You can also just estimate by looking at the graph because that's what you will be doing on the AP exam too. So if you put something that was within a couple percent of the actual number, it'll count it correct. So for this one, it would estimate that it's something a little bit less than 10%, a little bit more than 5%. So 7% is a good guess. And the actual value was 7.18% based on the numbers of the graph. And the last question asks you to imagine in this problem 32 individuals are born in 1 year. Approximately how many are still surviving in 7 years? So this is a percent of problem. And the formula for that, how you think about those problems, is you just do the percent as a decimal and you multiply it by the original value. So trying it with this one, 7 years, so I have that already showing up. We'll put 12.4% are surviving at 7 years. So we want to change that percent to a decimal, which you move it over 2 times or divide by 100, which would give us 0.124, and then multiply that to the starting value, which was 32. So I'll just go ahead and answer on my calculator here. 32 times 0.124, and that answer is 3.96. And obviously you can't have a part of a frog, 3.968 frogs. You can't have 0.968 frogs, so you want to round it to the closest whole number. So we're going to say approximately 4 frogs. And that's it. I hope that helps.